Hi, everybody. What's going on? Beautiful day. Glad to be here. My name is Garrett. I run a fund called Permanent Ventures, and we focus mostly on like decentralized applications, which are set up to exist forever and have, just be very long-lasting with the right token economics and incentives, such that, ideally the projects will survive the founding team. I just think that's one of the most interesting, aspects of crypto is like, the ability to create things which survive, beyond the creators, which isn't as often the case in traditional companies. So, today we'll be talking about, the decentralized storage landscape, specifically about VMs that are emerging. So we'll start off just giving a little bit of a, overview of all of the competitors throughout the past that have, started decentralized storage projects. Some of them have pivoted into, decentralized compute, and others have become a little bit too centralized to be considered anymore. It's a space that I've personally been following since like Storj and Swarm and some of the earliest attempts. Today we're left with the kind of most popular four: Arweave, Filecoin, eTstorage, Swarm, and of those, the two that are most used and that are actively developing their own virtual machines are just Arweave and Filecoin. So those are the two that we'll compare mostly. And so the respective virtual machines that they're working on. Arweave launched a testnet of AO a couple months back, which is a actor-oriented message passing network. And Filecoin also launched a actor-oriented message passing network like a year ago in March. And it's really interesting to see I think in particular, like the convergence of the two networks in terms of their storage offerings in particular, because of what a more generalized virtual machine enables. So we'll talk a little bit about that too. There's a bit of background to this talk, which you might be interested in if you're interested in these two networks in particular. This was like a similar kind of talk, just diving into the protocol differences, because now we'll just talk about the virtual machines. And there's actually a lot more that's different on the protocol side. Can recommend that as like a attempt at a relatively unbiased comparison between the two. And there'll also be a link to these slides at the end. So. Just a little bit of an overview on what was discussed in that talk was these are like, if you really boil it down, like the key differences. So there's everything from obvious like language implementations to the validation proofs and but the main differences that are important to note is that Filecoin is its intentions are to be like a decentralized broker of storage. So then you have sellers and buyers of storage facilities, and you enter into time-based agreements on how long you want this storage for. And it does great at that. Arweave is a protocol which has an endowment built in, which guarantees that if you upload something to the network, it will pay out rewards to miners indefinitely, like in perpetuity, ideally, making some game theoretic assumptions and so on, that the storage will always be there. So there's a couple nuances there, but you can look at that to dive into those. The main topics of interest for today's talk, virtual machines and the applications we can build on those. Main thing important to note is that I think the convergence of storage offerings is pretty interesting. Like, so Arweave as a permanent only, data storage level layer through the use of a virtual machine can offer term-based storage for the first time. And Filecoin, on the flip side, through the use of a virtual machine can offer perpetual storage. So, the offerings converge, and that's pretty interesting. Because of each of those initial protocol level trade-offs, how virtual machines are implemented is obviously going to be different. I think probably the most interesting use case for these networks is going to be like autonomous agents and AI inference in a truly decentralized way because of the nature of each of them to run like arbitrary levels of compute. So Yeah, there's a big difference here in the two kind of virtual machines that are initially supported on each of the networks. Filecoin virtual machine is focusing on making a version of the EVM that runs natively, so then you can easily port over DeFi primitives and so on. And so far, it's mostly used for like Filecoin restaking and lending to miners, so then they have more liquidity and access to being able to scale up their mining operations without needing to put up as much capital up front, which is great. WebAssembly though is like natively and inherently like just much more flexible in what you can do. Especially after we get over this initial limitation with WebAssembly 1 only allowing up to 4 GB of memory. So for instance, if you wanted to run some kind of language model inside of WebAssembly under AO or under FVM, once they support that, then you can, not right now you're limited to like a LLM, which is slightly less than 4 GB, right? So it's not as interesting. So for example, like if you guys use ChatGPT or something like that, you'll want to be using a model that uses much more RAM than that, maybe up to like 30, 40, 50 gigs. So once we can run those kind of more serious models inside of this decentralized compute paradigm of these protocols, leveraging the data stored on each of them, it's really fascinating what we can do. Something that Arweave are working on implementing with AO is like that 64-bit memory space, which will be really cool. Both of them, AO and FVM, are VM agnostic. FVM are starting by implementing EVM. And AO are starting by making WASM the default. But the idea with both of them is to make it so you can plug in your own VM, whatever you want to use. And that'll make it very flexible in terms of what can be run on the networks. Both networks use an actor model, so basing on message passing, which is great for like massively parallelized compute in a decentralized way. So I thought I'd put up like what is the actor model here, but basically it means that each node on the network or agent that's executing code is communicating with others just by message passing and acting based on when they receive a message and send it back. So that way you can run like a massively parallel computing paradigm instead of having like a monolithic state like we're used to with most blockchains today. So where they start to get a bit different is is kind of like the intentions of what's being built out first. So in FVM you have the FEVM, whereas in AO you have this interesting like SSI model where you have a kind of initial image that you boot up from, and then there's different roles within that can be assigned to the node that you spin up. So you can schedule tasks, you can do compute. For instance, some compute units will be good at CPU, some will have GPUs attached, and others that are meant for sending messages. And then with AO, of course, you can think of it as L2 that settles on Arweave, which of course inherits its security. So I think I just said that, but EVM first versus message passing first, but eventually, the convergence between these two networks will probably be even stronger and more prevalent when AO will also implement like an EVM, and FVM will also implement like ways of doing message passing. So right now they're quite different, but ideally, if they both materialize in like the visions that they have, then it should look pretty similar in the end, which is kind of cool. I think it's very validating for each of the projects that they want to go in such similar like end directions. But both of them will be able to manage storage deals through virtual machines, which is really powerful for implementing the perpetual storage on Filecoin and temporary storage on AO. Doing compute on data that's natively stored on each of these blockchains and storage platforms is really interesting. So having native access to large amounts of data and being able to do compute on those without needing to worry about transporting that over the internet over long distance and having the nodes that do that compute, maybe even in the same computer or the same data center, can be really, really good for optimizing for cost in like a decentralized compute paradigm. So probably like the most interesting thing that's going to occur here is in AI inference. FVM will be well equipped for this because they've subsidized mining to such a huge extent that there's been a massive infrastructure build out that has very high levels of like compute on GPU and CPU and RAM. In data centers all over. So the miners on that network, even though currently it's a lot of the miners are kind of winding down or going dormant because the subsidies for mining are decreasing, there could be a lot that's just waiting for the use cases in like AI inference, for example, to come back online, and then the infrastructure will be there, which is pretty cool. AO is taking more of like an organic open model where people will join the network without massive upfront subsidies, and hopefully like it'll be driven by just demand in the marketplace as it has been so far. Historically, inflation and like levels of subsidies for miners on Filecoin has been pretty high. It's lowering a lot. But consistently throughout for Arweave, it's been low. So there's been like less network build out, but it's always just kind of kept up with the demand for storage. And then the storage offering convergence. We discussed this already. I think it's going to be pretty fascinating because of the implications that each have. But so key summaries are you got the actor model, native storage access. And the main thing is the convergence. And for differences, FVM is focusing on being a hypervisor and a normal kind of EVM blockchain first, implementing WASM support later. AO's more general system image that you can load up and boot whatever kind of process you want inside of, and then pass messages around to other nodes. So right now, that's what that's looking like. And then the kind of how that's evolved over the past like month or so is mainly like I would have been a lot more kind of unbiased like a month ago, I would say. Saying that like let's see what happens with these two. But in the past month, the amount of like developer attention on AO has been like massive. I think because the kind of AO team are building way more quickly and way more perhaps scrappily, just kind of like putting stuff out there, iterating fast, not being too worried about the implications because it's just a test net. There's less to worry about naturally. So that's allowed developers to experiment a lot faster and attracted people that are building like autonomous AI like agentic systems on top of it, starting new DeFi primitives and building like stable coins and dexes and all the kind of stuff that you would need from scratch as well, instead of like porting it over from EVM. So it's interesting to just see like all the opportunities that emerge through like a more WASM native virtual machine. And then because FVM is in mainnet already, and I think in general the team there are much more cautious about rolling out new features and so on. It just evolves more slowly. Obviously it's super important to make things secure. So it's probably smart of them to do that as well. But yeah, it's just really exciting times right now, kind of in the AO ecosystem. So I could encourage developers who are interested in like building a new compute paradigms to build that out. But yeah, that's all I've got for you guys. So thank you, and let me know if you got any questions.
Hey, hello.
Hey.
Thanks for the presentation. That was good. I wanted to ask, so if there's all these DeFi primitives starting to happen on AO, say. You see in the future that like the liquidity also like as it is now between L2s, is it also going to happen? You think it's going to happen also with AO? There's like even liquidity going into that, which splits with all these other chains.
Yeah, for sure there will be bridges, and like you'll see integrations with really popular bridges onto any network where there's opportunity for sure. So yeah, there will be like liquidity moving between like AO and other L2s and so on for sure. But having a natively implemented, like stablecoin, for example, is also nice. So until like Tether and Circle like USDC come and say like, okay, we're going to deploy our own smart contracts natively and natively support AO, for example, or whatever other network it might be. It's really important to have like a native stablecoin that's not dependent on some third-party bridge that not everybody would necessarily want to trust. So, yeah.
So are people rebuilding the DeFi primitives in WASM now on the AO chain?
Yeah. It's definitely a lot of work, but it's and people are also building like a EVM compatible chain that sits on AO as well, and doing that. So yeah, both are happening. Yeah.
Okay. What are you more, bullish on? Like, what do you think makes more sense? Because like reinventing all the DeFi primitives in WASM doesn't sound like very, like, do you want to repeat all the bugs that like the EVM had at the beginning? Or like stuff like that.
Yeah, that'll be a lot of extra work for sure. But in the short term, for sure, just like copy pasting, things that are already audited, definitely makes more sense. But in the long term, I think having stuff like natively in WASM on AO will be very interesting. Like there'll be just more like things you can do. It's like less limited as a environment. So yeah, both are necessary. Well, I guess you're doubting the necessary word, but but I think it's fun to see.
One question, since
Yeah.
I came super late, so I missed. Can you give us a 10-second TLDR of AO versus 10 seconds?
Can you put the slide back up? Okay. 10-second difference is okay. We got mainnet on file like FVM that's been around for a while. They're focused mostly on building an EVM inside of it first. Which is what you can use and enjoy today, like staking fill and lending it to miners and so on. And AO are focused on WASM first. So I think that's the most important TLDR difference. Yeah. Cool. All right. Thanks everybody.